Hi everyone. Today we are going to talk about sampling theory. Uh, Most signals in nature are found to be analog, and analog signals are facing difficulties in processing or storing. That is why we are shifting towards a digital processing of signals. So by doing a digital processing, we able to store a signal, we can retrieve information back, and at the same time we can reproduce the signal in its original form. So, considering these advantages of digital signal, we often have conversion of analog signals into digital form. For that purpose, we understand how can we sample the analog signals such a way that we convert into digital form, can process it, and we can reconstruct it back. Okay, so let's look at the outline. So first thing we're going to talk about analog frequency. We are familiar with analog frequencies, analog signals. But when we talk about sampling of analog signal, another frequency comes into the picture which referred as a digital frequency. It is important to differentiate the analog and digital frequencies. At the same time, we must understand the mapping between those frequencies. In other words, you can say if you have an idea about digital frequencies and sampling rate, you must be able to map content to actual analog frequency. So that is the requirement for understanding analog and digital frequencies and the mapping. Following to this, we must identify the best possible sampling rate for given system or given analog signals. The reason is inappropriate defined sampling rate may cause aliasing or it refers as a loss of information. So we must ensure that whenever we sample a signal, we need to sample in a such a way that we can recover it back after processing. So for that, we should identify the best sampling rate without sparing alias. So we see in graphical way how this aliasing is occur for inappropriate choice of sampling rates, and we can determine a best possible sampling rate by graphical means. However, it is important to see the mathematical insight. So we'll discuss a formal introduction of representation of the sampling theory in a mathematical way, where we're going to analyze the sampling process in time domain as well as frequency domain. For representation purpose in frequency domain, we often compute its Fourier transform, and through Fourier transform, we can analyze the sampling process and we conclude with the sampling rate. So that's all for this lecture.